How to teach multiplication the easy way. Skip counting is the most important thing your child can learn in elementary school math. Nearly everything they'll need to be able to do by 5th grade requires them to be able to learn this skill. Unfortunately, most children today have no idea what skip counting is, why it's important, or how it's done. It's true that we live in an age where computers do our calculations for us. But in the case of elementary math, children need to learn to skip count in order to have an understanding of basic math concepts like multiplication, area, common denominators, and even the number line itself. Just getting the answers to multiplication problems on a calculator won't provide them with that kind of mathematical literacy. So if we're a math teacher or a math coach, what can we do to make all of this easier for our students? There's a way to break down the process that's interesting, fun to look at, and easy to remember. First, we're going to figure out which numbers are easiest to skip count, which ones have nice patterns. Then we'll figure out what to do with the others. What we're really teaching is adding and multiplying certain numbers. So, for instance, instead of memorizing 5's times tables, we'll teach students how to skip count by 5's. This way of learning math has a lot going for it. First, it shows you how numbers grow, and in some cases, really pretty patterns appear when they grow. Second, when you're counting by numbers, it sets up a kind of rhythm. It's almost like music. Schoolhouse Rock cartoons from the 70s taught a whole generation of kids how to skip count by numbers when they found the innate rhythms in them and set them to music. We don't have the budget to hire the best musical talent to help us. So instead, we're just going to teach children some skip counting techniques. At first, they'll have to write a lot of these things out, but the more they do it, the easier it will be for them to remember them. Are you ready? Let's go. 1 is the easiest number to count. Anything you multiply by 1 stays the same. 9 times 1 equals 9. So counting by ones is just counting. 10 is also easy. Anything you multiply by 10 just gets a 0 added to it. 3 times 10 equals 30. So counting by tens is just counting by ones, with an added 0 after each number. That's 2 out of the way already. 5's are pretty easy too. If you count by 5's and line up all the numbers top to bottom, you'll see something very helpful happen on the right. It goes 5, 0, 5, 0, 5, 0, like a light blinking on and off. The numbers on the left are pretty easy to figure out too. After the first 0, you just count from 1 to 10, using the numbers twice each time. So now you have this list of numbers starting at 5 and going all the way up to 95. And if you want to multiply by 5's, you just count down the row. 5 times 6 is 30. The next group are a little harder, but the patterns are easy to see, and they're kind of pretty. Counting by 9's seems hard, but there's a really great trick to that one. Start by drawing the numbers 0 to 9, top to bottom. That's your left column. Once you get to the bottom, create a right column and go from 0 to 9, going back up. That's it. You're done. Counting by 9's. Want to multiply? Count down the row. 9 times 6 equals 54. Counting by 2's is no big deal. You can see that you always get the same 5 numbers in the right column. 2, 4, 6, 8, 0. Again and again and again. If we need a fun way to remember those, we can draw a kind of clock, but with 10 numbers instead of 12. If we draw lines from each number to the next, we end up with a pretty shape. A pentagon. Counting by 8's seems hard, but look what happens when you line them up. you get the same patterns as the 2s, only backwards. 8, 6, 4, 2, 0. The numbers on the left are a little trickier to figure out, but if you think about it, you're always adding 8, so the number on the left will usually go up by 1. The only time it doesn't is when you go from a 0 to an 8, like 40 to 48. We can draw these on the clock too, and we end up with the same pentagon as we had with 2s, just going the other way. So that's 3 easy numbers, 1, 10, and 5, and 3 pretty easy numbers, 2, 8, and 9. That leaves 4 numbers which aren't so easy: 3s, 4s, 6s, and 7s. There are patterns for these, but they're a little harder to see, so we need a nice trick to remember them. Let's start with 4s. If we count by 4s, we see that the pattern in the right column is 4, 8, 2, 6, 0, and it repeats. That's not so easy to memorize. What if we drew our clock? Let's connect the right column numbers with lines and see what we get. It's a star. That's easy to remember. So if we want to memorize our 4s pattern, we can draw our little clock, start on 4, and go around and make our star, maybe adding a little arrow to remind us which direction we were going, towards 8. Now if we want to remember how to count by 4s, we have our star to remind us. What about 6s? The pattern here is 6, 2, 8, 4, 0, and it repeats. What if we draw that on our clock? It's the same star. We just need to start at 6 and draw an arrow going towards 2. So now we have an easy memorization device for 4s and 6s. A pretty star. What about 3s? The pattern for 3s is pretty, but not so easy to understand. The problem is that it goes through all the numbers once without repeating. It's 3, 6, 9, 2, 5, 8, 1, 4, 7, 0. How are we going to memorize that? Well, let's draw our clock and start connecting lines. Let's see what happens. The pattern is another kind of star. It's complicated, but if you look how it's drawn, you can see that after the first 3 numbers, 3, 6, 9, you're always going to connect to a number lower than the one before. 3 to 2, 6 to 5, 9 to 8. Yes, this one's trickier than the others, but look what we've done. We've gone from asking a child to memorize 10 sets of times tables to asking them to remember 2 easy stars and 1 hard star, with the other patterns being really easy. So we haven't eliminated memorization, but we've made it a whole lot easier and a lot more fun. Wait, what about 7? That pattern looks really freakish. 7, 4, 1, 8, 5, 2, 9, 6, 3, 0. Is there anything we can do about that? Sure. Draw it on the clock. It's the same as 3, only backwards. Memorize 3, and you've got 7. So when we have multiplication problems to do, we only really have to draw 3 things on our scratch paper: the pentagon, the 4 star and 6 star, and the 3 and 7 star. The rest of the patterns are easy to recreate. Of course, there's another nice trick when it comes to multiplying. Let's say students just hate multiplying by 7, even though we gave them our great little picture. Okay, we say, no problem. Take any 7 problem, turn it around, and it's the same. Don't want to do 7 times 2? Just do 2 times 7. It's the same problem exactly, and the 2's pattern is easier to remember. Hate 7 times 9? do 9 times 7. That's a much easier pattern to remember. And if a child knows this trick, then they'll understand the commutative property of multiplication, a powerful concept that they'll need all the way up to graduate school. So if you hate drawing the complicated stars, if you never want to multiply by 3s or 7s, you can usually turn the problems around to numbers that have easier ones. The only problems are 7 times 7 and 3 times 3, which you would have to memorize. They're 49 and 9, but that's a lot less to memorize than 100 times operations. Now, a lot of times tables go to 12. The pattern for 11s is pretty nice, at least for the first 9 operations. Just create pairs of counting numbers. 11, 22, 33, and so on. And 12s is kind of like 2s. The right-hand column is 2, 4, 6, 8, 0, and you just have to remember that the left-hand column is a little bit wonky. But there's a safer way, even if it takes a little longer. Multiplication problems can be broken up into addition problems. So if you have 12 times 6, that's just 10 times 6 added to 2 times 6, because 10 plus 2 is 12. Those are both easy patterns to remember. So instead of one harder multiplication problem, you have 2 easier multiplication problems and 1 addition problem. 60 plus 12 equals 72. This is really good for numbers larger than 12, which get very messy very fast. Yes, they can learn the standard algorithm for multiplication, but all that does is this exact same thing. Creates a method for adding various multiplication problems together. So they can do it implicitly with the algorithm or explicitly where they can see what they're doing and understand the process. In any case, it's a lot more fun to teach these ideas than it is to drill 25 third graders in the multiplication tables. I hope this has been useful to you. If you have any questions, you can contact me at adam@acol.net. Have fun.